Hello everyone, this is Lateral, civil engineering student in Whole Technical University. So today we'll be tackling lateral earth pressure question using the GO5. So as you guys can see on my screen, you guys can see a sample lateral earth pressure question with a support depth of 7 meters, having two profiles, one at a depth of 4 meters and the second one at a depth of 3 meters, which is the dense sand and the loose sand, with groundwater also passing through the depth of 4 meters exactly, with the swells having their own properties and a surcharge load of 15 kilopascal on the top of the profile. So with this question, we'll be using this question in GO5 in order to analyze the force acting upon the support and the centroid of the force, or the location of the force that is acting upon the support. So to start with, we first go to the GO5 folder, then we activate the earth pressure template in order to solve our question. So let's wait for our earth pressure template to open. Now, okay, so the first thing we do is we head over to our project. We name our project using the project data here. So after naming your project, you can continue by coming back to settings. So now when you come to settings, you will see that our pressure analysis is being done using the verification method of safety factors. The active pressure calculation is used by columns, and the passive pressure calculation, they will be using columns. But since I'm familiar with rankings, I'll head over to the edit tab here, click on it, and it will load here. So when this loads, I'll change the active pressure calculation to rankings, and the same I'll do for passive pressure too. So after I'm done, I click on OK and I proceed. Now we have to head over to our drawing in order to see the properties of our geometry in order to continue. So what I'll do is I'll head over to my drawing and I'll split the screen. And when I split the screen, I'll continue with our work here. So let me minimize this a bit so that we can still continue. Yeah. So now so now this my screen that I've splitted, and we can now continue. So now in the geometry, we are having the support to be at a depth of 7 meters. So what I do is I head over to geometry in my work, and when I head over to geometry, what I do is I come to the depth here, which is allocated here, click on it, and when I click on it, I'll just do edit, and when I head over to the edit, I type the designated height or depth. So when I click on it and I click on OK, and you guys can see that the depth has changed. Now from there we go to profiles. When we head to profiles, since we're having two profiles in our work, what I do is I do add. So I come to the add button here and I add. So now the first layer is starting at a depth of 0, which is on top of the support. So I'll click at depth of interface to be 0, and I'll come and check the thickness of layer here, and I'll make it 4 meters since it is 4 meters thick, which is the loose sand. So I'll do 4 meters and I add. So as you can see, it has been applied at this section. So now the second layer is continuing from that 4 meters and is having a thickness of 3 meters. So as you can see, the depth is now at 4 meters and it's having a thickness of, so I'll change the thickness to 3 and I'll also add. And as you can see, we are having 2 layers here. So if you are done, you just cancel. If you still have other layers, you continue. So now from here we head over to the source section. So now I click on source section, and you guys can see that we are having not input because we didn't add anything related to the swirl. So what we also do is we come here, click on add, and we have the properties allocated here. So the first sand in the question here is loose sand, so let me name it loose sand. So now the unit weight of that particular one is 16 kilonewton per meter cube, and that 16 kilonewton per meter cube is the effective unit weight. So now what we have to know that is what effective unit weight is what is the saturated unit weight minus the unit weight of water. So since this is effective unit weight, we are going to input the effective unit weight at this section. So we'll be inputting the 16 kilonewtons here. So now the angle of friction, we have it here as what 32. Then the cohesion is 0, but since it doesn't take, we type something close to 0, something close to 0 here too, so 0.01. Then now when we come to the saturated, since the effective is the saturated minus unit weight of water, which is 9.8 kilonewtons per meter cube, to know the saturated of the effective, you have to add the unit weight of water to it. So here will be 16 kilonewtons plus 9.81 kilonewtons per meter cube, all amounting to 25.81 kilonewtons per meter cube. So this is what we'll be putting here, and from here we add. Now you can see here at the bottom side of the screen that it has applied to our template. So now we also have another one, which is the dense sand. So we can equally come here, change the loose to dense. So now after changing it, now the unit weight here is effective unit weight, but in the question we are having a saturated unit weight here. So all we know is what, to know the effective unit weight from the saturated unit weight, we have to subtract the unit weight of water. So now the unit weight here is saturated, which is the 19 kilonewton per meter cube. So to come to our work, we come here and we type 19 kilonewton minus 9.81 kilonewton per meter cube, and now our effective unit weight will change from here to 9.19 kilonewton per meter cube. Now we come to the angle of internal friction and we change it to 38 degrees. This and this, we maintain them as such. Now the saturated unit weight, that's where we type our 19, because I said earlier that this 9.19 plus a unit weight of water, that's what is going to amount to the saturated unit weight. So after that, we also click on add, and if we have any other soil type, we add. If not, then we also cancel. So from here we move on to assign. So we click on the assign, and after clicking on assign, you see that what the soil have been assigned to the profiles. So what we have to do is, now if the soils are not rightfully assigned to the profiles, we change them. So the first one is profile 1. So per our question, we are having loose sand there, so we'll maintain it like that. Per our profile 2 is dense sand, so you click on the second one here and you click the drop down menu and you change it from loose sand to dense sand. Now our third profile, which we didn't apply, was not considered, so you can equally maintain it as dense sand, or you can equally click on not assigned, which I will maintain it as dense sand. Okay, so after this, you guys can see that the profile and the soil type is matching with the one we can see in our question. So you're having loose sand here, and we're also having loose sand here. We're having dense sand here, and we're also having dense sand here. We're having it at 7 meters deep as the total support, and also everything here is coping. So the next thing we go to is our terrain. So sorry for my drawing, it looks a bit inclined, but it was actually meant to be straight. So when you check, we see that what our soil which is being supported is exactly at the same level with the support. So we maintain the first one here, which is already in place. Now we move from terrain to water. So when you move to water, that's where we are going to put in where the water table is. So per our drawing or per our question, the water table is exactly 4 meters deep. So we have to come and select our water table. So we just glance through the first one, and this looks exactly like what we have in our question. So now the only thing is the H1 here is 1, which is even indicated here in the working space. So what we do is we click on the H1, we change the height to 4 meters. So when you click on 4 and press enter, you see that your water table will now move from wherever it was to the designated one in your question. So now after we are done with our groundwater table, we then move to surcharge. So now after we move to surcharge, we are now going to choose the surcharge that is going to be on top of our question. So in the question we have a surcharge which is Q of 15 kilopascal. So we also come here to our working space, we click on add. When we click on add, we are going to see it here. So now the surcharge, we have to name it. So since it's been named here as Q, let me also name mine as Q. Now the type of surcharge is a surface surcharge, as you guys can see. So depending on the question you have, we have surface, strip, trapezoidal, point, line, and horizontal. So the type of surcharge that is being given to you in the question, you select it and you do. But per this question, we are doing a surface load. So I click on the surface load, and it's also a permanent load. So I'll keep it as permanent. But if it's not a permanent load, you either know whether it's a variable load or an accidental load. So I keep it as permanent, and the value there is 15. So we all know that 15 kilopascal means 15 kilonewton per meter square. So I also type in the 15 there and I'll add. So after I add, you guys can see that the surface load or the surcharge is being applied to my drawing also in my workspace, as you guys can see. So now the next thing we go to is what? The earthquake. So with the earthquake, per our question, we're not giving anything related to earthquake, so we won't be using the earthquake tab, but rather we'll jump on to the analysis tab. So when we click on the analysis tab, we are going to see that what? We are going to see the graphs showing the geometry of structure, which is here, the horizontal component, which is showing the overall force and the depth of our centroid, and the vertical component too, with the overall force and the depth of centroid. So this is how our drawing is going to look like, and this is the force which is acting. So the force is 168.70 kilonewtons per meter, which is acting at a depth of 4.62 meters. So in terms of horizontal component, we are only having the force, but in terms of the vertical component, we are not having any force here. So this is how we calculate for lateral earth pressure using the GEO5. So someone also asks, how do we do print or how do we do save? So GEO5, actually, when you go on for a trial version, you see that when you click on save, you can't save. But when you are using a paid version, as I'm using, you can equally save, like the way we save in our normal Microsoft Word. We click on save button, we type in the name we want to save it, and we save it as our location. Then we go on. And also, one cool feature about GEO5 is you can also generate a report. So if you want to generate a report, you head over here, you can see it clearly there. That is generation of what? A detailed documentation. So you click on it, you can see the reports generated here. And in the report, we have several things that are in the report, which are at the left side, and some are ticked and some are not checked. So if you want something to be checked, you have to head over to this section, you check it, and it will be applied in the report, as you can see. So if you don't want something, that's where you come here and you also uncheck it. So we'll do a sample. Let's head over to the resultant forces. So we have resultant forces here in our chart because it is being checked over here. So the thing we will do is, when I uncheck it, you guys can see that the resultant force has left, and when I check it back, it will come, as you guys can see. So this is how we do lateral earth pressure calculation in GEO5. I'm Lateral, civil engineering student, Old Technical University. Thank you.